like this, if you have 7-bit B0 to B6, right? This is 1, 2, 3, 4, 5, 6, 7, right?
Yeah.
B2, B3, B4, B5, and then somebody wrote to you like 0, 1, 1, 0, 1, 1, 0, like that, right? I'm
Yeah.
asking you attach a parity bit. So in the parity bit, so this is a parity bit will be, which is B7, right? Let me just push people in. So if you look at it, right, what is the job of this parity? Gonna be odd or even,
Correct.
right? So if it's odd, then the eighth location or the 8 digits, they have to have what? Odd numbers of 1. If it's even, the eighth location will have what? Even number of ones. So for instance here, right, 1, 2, 3, 4. Oh, those 4. So I have to make this 1. So they're gonna be 5. So gonna be odd number. But if it's even, then 1, 2, 3, 4. Naturally, is what? 4 even. So I don't need to add anything. So gonna be here 0.
So would that be considered an 8-bit since you added the
It is 8-bit. It's 8-bit
Okay.
including parity bit.
Okay.
That makes sense?
Yeah.
Any other question regarding the previous lectures before we start moving to the current lecture?
I was just wondering where you use this parity bit. Is it for like communication? Is it just to
it is communication or data transfer.
Oh, that data transfer. So it's just to make sure that the data that you are expecting is correct.
It is not. Yeah, it is not. It is not fixing data more than just a kind of a flag telling you whether this data corrupted or not.
Interesting.
Because if the data is corrupted, then you don't have the mechanism with the parity to fix. The only thing you will have in hand is basically to ask for resending. There is something else. There is a branch of science. It's called error correcting code. So like a Red Solomon code, and most of the NASA error correcting code they use, because messages coming from Mars to the Earth is already have a bunch of the electromagnetic waves from the sun and the rest of the planets and asteroids and whatever. So that means they have to be sure all of the error correcting server running, so they will have 100% sure that the data is right. It's not like the data can be significantly causing a big damage. For instance, if you are directing a rocket, or if you are making what's far distance surgical operation. So you have the robot inside the surgery room, and he's applying all of this bunch of knives and whatever on the patient. If there is a little bit miscommunication happen or missed data or corrupted data happen, he might actually cut something really critical, right?
Yeah, that sounds pretty dangerous.
Yeah, no, but believe it or not, there is now, because everything is now based on internet, right? So there is an IoT, for instance, right? Internet of Things. My iWatch is connected to my phone through the network, right? Is using Bluetooth, for instance, for transferring the data about my biometrics to my phone, right? So maybe this is less important, less sensitive, but what about if I'm actually connected to a device like a pacemaker, and the pacemaker into the network, and then it's connected to my doctor office, and is monitoring my my heart behavior the 24/7. Then
that's pretty cool.
You understand? So there's a bunch of, so that's why we starting with the digital logic design. Makes sense?
So
yes.
What's the difference with even and odd? Is it just like user preference?
It is, or it depends on even higher level of the system. Maybe the designer, he found out that less resources will be used when he will apply odd for a specific situation, or maybe he will find out that even is much more appreciated for other certain application, and so on. I mean, It depends on the
Mm,
application. It
interesting.
depends on the preference, as you said, and it depends on even the cost performance.
Oh, there's a cost. So it's like one system is the odd might be better than even as a whole.
As a whole system. But
Gotcha.
maybe for this specific piece is not important, but as a whole system, it will be different.
Very interesting.
Okay.
Yep.
Any
Thank you,
other
sir.
questions? So anyway, we already talked about last time the beginning of the real course, which is the logic gates and the Boolean algebra, right? So here, Boolean algebra and logic gates. And we mentioned that there are three essential gates or exist based on the Boolean behavior or Boolean algebra, and we call them and, not, and or gates. And there is an operator belong to them in the Boolean algebra, right? Like if you do it like this is actually and. If you make it like add, it's gonna be or, and then negation, it's gonna be the not, right? And we described for every single gate three different things. We came into something called truth table, which is something you're gonna commonly hear during this course and even the rest of the classes until you will be like the most important like influence engineer in the world. Based on that, you're gonna use truth table. So we use truth table, which is a kind of like describing the transfer function. And when I say transfer function, it means that the relation between input and outputs, right? Also, we talked about how the symbolic of the gate. So why symbolic is important, because we're gonna make implementation. And to make it very clear, it's called gate level implementation. Gate level implementation. Then we described the truth table based on the equation with respect of the Boolean. So it's going to be a Boolean algebra equation, right? And from there, we start playing with some, facts, right? We came into like x ORed with x complement is equal 1. We came also to another conclusion, which is x complement is equal 0, right? Those are very important. We're gonna use them a lot. Then we made some play like x, for instance, ORed with 0 is x, x, for instance, ORed with 1 is 1, right? And also I didn't talk about this, but it's very straightforward, right? What about if it's x ended with x? What will it be?
X.
Should be x, exactly. And then what about x ORed with x? What it will be?
Also X.
Exactly. Even though it looks really simple for us, but it's important later on when we will work on something is called gate level optimization. Gate level optimization. Okay. Now, or to be honest, last time we were talking about De Morgan. For fun, I call him Captain De Morgan, but just take it De Morgan. So it's the De Morgan's theorem, right? And in the De Morgan, we have a very nice way of breaking the complement in a big set of variables. So for instance, if I say that f as a function of x and y is equal x ORed with y, and then the whole entire thing will be complement. De Morgan helped us to break it up in a way that by the end of the day, it will help me to do what? To optimize. So what De Morgan said, De Morgan, very easy, you know. He said, I'm gonna distribute the complement on the participants of the whole entire function. So who are the participants? So the participants are X, the participants are Y, and then, you know, the operator itself is a participant. So the operator, what he said, if you complement the OR, it will be not, it will be AND gate. And if you complement the AND, it will tend to be what? OR. So in that case, this is gonna be X complement ANDed with Y complement. That makes sense? Which, if you like to try your own git level implementation, how are you gonna do it? If you like to do it before the distribution of the complement, you're gonna do it as an OR, taking X and Y as an input, and that will be followed by an inverter, which is not gate, to bring me what? F as a function of X and Y. Do you guys agree? If you,
Yep.
yes, if you like to look at it now after, you know, we distributed, it's gonna be what? X, sorry, complemented, that means not gate is involved, and then followed by another not gate for Y, and then an AND gate will be taking the whole entire thing to produce to me F and X and Y. Do you guys agree? So this implementation is exactly doing the same job in terms of functionality as this implementation, based on the distribution of this complement using the De Morgan theorem. Does make sense?
And then if you wanted to go back from X naught and Y naught,
I will
it would
show you.
be
You complement
okay.
one more.
Oh, okay.
That's actually the second thing I'm going to talk about now.
Oh, thank you.
So look, you know, if I say like this, X, Y, complement, complement, right? Let's do it. So gonna be what? X complement, Y complement, and there is the other, oh, scheiße, I'm sorry. And they're gonna be the extra complement, right? Then I will take this one. So I will do it what? It's gonna be X complement, complement, and then, you know, Y complement, complement, right? Let's think about it, right? If X is 1, right? X is 1. If I complement 1, it gives me what? 0. If I complement it one more time, it will give me 1. So what I'm saying here, if you see here, you know, even number of complement in the top of each other, that makes that, you know, it's equivalent to the original, right? So for instance, if somebody tell you like this, X, Y, 1, 2, 3, 4, 5, 6, 7, 8, what is this will be? You know, you just like close your eye like this, just say it's X or Y. Do you guys agree? If somebody's telling you, for instance, X or Y, 1, 2, 3, 4, 5, 6, 7. So what is this? This is exactly equivalent to X or Y, like that. Because I took the couples here. This is 1, this is 2, this is 3. Then the only one is missing is what? This one. And that's gone here. Does make sense? Everybody's following?
Yes, thank you.
If you have any questions, you know, no rush, you know, I'm very slow. Later on, I will be very fast. So, so be careful.
So let's say we have multiple different X and Y variables, right? On when you do a schematic, you can look at it and, like, you know, cross out the gates you don't need. But when you're actually doing it in like these kind of terms, how would you?
We are talking now about optimization. So you're jumping to something important, which is called optimization.
Slow down, Kush. Slow down.
So I'm very slow. I like, you know, slow down. Anyway, okay. So now we need to start using all of the knowledge we learn about the Boolean algebra for doing simplification or optimization. So some of the books will follow a notation called simplification. Some it will tell you that reduce number of gates. Some other of them will say that, optimize, right? So if we stick, for instance, with a function of x, and what is this equation is based on this x, is basically is an x ended with a combination of the x complement and and y here, and it's asking you to simplify this combination. So we're gonna start use whatever we learn, right? So we have to do here what distribution. So we're gonna distribute, right? So gonna be x complemented. That's actually gonna be and then ORed with x ended with y, right? Then what we learn about this one is equal what? We did it before. Is equal what?
0.
0. So that means, this is 0 plus x ended with y. And, we learn about this what? It's basically like 0 ORed with x, right? Same thing. So that's going to be equal to what? X, y. So using the postulates, we started with like in the middle of the lecture last time, and starting now, we figure out to decrease the number of gates from having here, AND gate with OR gate and NOT gate to just have what? An AND gate. So this combination was using what? One AND gate with one NOT gate with one OR gate. Do you guys agree? It turned to be we are just using one AND gate. Easy? Let's make it more difficult.
For
Right?
x times y, we get the same as if we do the before the simplification of adding 0.
Yeah, what you can do, there's a way to prove whether that this one is equivalent to this one. How can you do it? It's pretty much easy, right? You can just make a truth table, x, y, and you call this f2 and you call this f1, right? And then you will just sort here output as an f1 and f2, and you try to draw the table based on how many inputs we have. 2 input, right? 2 input variables. So that means how many states this table will be covering?
4.
4. So gonna be 1, 2, 3, 4. 0, 1, 0, 1, 0, 0, 1, 1. Right? Then we'll start applying state by state into the first equation, and we start putting the output here. Then we will apply again every single state in here, and we sort the output there. And then, if we find F1 and F2 are equivalent, that means they're equivalent. That makes sense?
Yeah.
And they are equivalent, by the way. So you can try it just like, to prove that, they are correct. So this is one of the way to do it, to check whether that your answer is doing the same thing or not. Right?
Would this be considered 4 bits?
What do you mean by 4-bit?
Well, what I noticed was that your x and y, right? You have 0, 1, 0, 1 and 0, 0, 1, 1. So your third one would be 0, 0, 0, 1, 1, 1, right? So wouldn't that follow like?
There is no bits here, right? We just have 2 inputs and 2 outputs. And I'm trying to compare between these 2 outputs.
Okay, so there's no relation there. Okay.
Okay. Those are outputs and inputs based on the truth table. So what we have now is truth table, right? Anyway, let's make some efforts. Like, like for instance, if somebody's telling you f as a function of x and y and z is equivalent to X ended with Y, or with X complement ended with Z, or with Y ended with Z. And I'm asking you to apply what? Optimization, or you simplify whatever we have in front of us, right? So one of the way to do it is actually to be tricky. One of the way to do it to be tricky. What is tricky? I will do those multiple ways in front of you. Let me think. We can do it with. Okay. So what we can do, we can come here and say that, you know, this term, we have 3 terms. Do you agree? Those are 3 terms, right?
Sir, Professor, do you need to put parentheses, or can you just go? Is there like order of operations? Okay, so and you don't have to do and first and then or kind of thing.
No, I mean, if you have and, you have to go with or first. I mean, or first. You understand what I'm saying? So for instance here, right? This Y ended with Z is equivalent to Z ended with Y. You understand what I'm saying? It doesn't matter the order of the variables.
Oh, but when you do the equation, this is the equation. Do you have to follow a certain, like, do you have to do X and Dex
Like this?
and,
Do you remember this?
yeah, that's
That's distributing. So you have to distribute now, right? It depends on how you're gonna do it, right? If it's the parentheses 0, you know, I will show you 1 second. If it's X ORed with Y, Z, X complement, right? Now they are the same, right? It doesn't matter. So you can just write it like this: X, Y, Z, X complement, right? If it's X ended with this combination, then you have to distribute, right? Distribute the X. So gonna be X, Y, ORed with the X, Z, X complement. Then you continue. Those together will be what? 0, because 0 ended with Z, 0, right? And then you're gonna be X complement here. You see what I did?
Only if there's an and, you distribute it. If it's an or, you don't need to distribute it. Okay.
We'll do more practice, you know.
Okay.
Anyway, back to this first. You know, we're here. Like, make a line here to break it, right? So if I would like to minimize number of variables, that's another way to say it. Simplify, minimize number of variables, or we call it literals, whatever, you know. Anyway, so Y ended with Z is equivalent to Y ended with Z ended with 1. Do you agree?
Yes.
For the rest of you guys, that makes sense?
I'm just trying to wrap my head. No.
no.
Could you explain it, please?
Sure. You know, if Y ended with 1, what is the output will be? It depends on Y. Right?
Yes.
So that means it's equal Y. If I write here, Y ended with Z, ended with X complement, ended with W complement, ended with V complement, ended with 1, what the output will be?
Everything before the 1.
Exactly. That's the same thing. So here, look. Right?
Oh, okay. Yeah, I'm looking at it backwards now. Okay. Left and right.
Yeah, let's look for the more fun. Now, this one, it can be something. It can be what? It can be Z ORed with Z complement, or it can be X ORed with X complement, or it can be Y ORed with Y complement. That makes sense? Because, you know, this is equal 1, this is equal 1, this is equal 1.
Okay.
Oh yeah, that makes sense.
So,
Sorry.
yeah, so now I can write X ended with Y, ORed with X complement, ended with Z, ORed with Y, ended with Z, ended with what? I like, as the Y and Z are there, to add X into that. So I can just write here X ORed with X complement. Sounds good?
Yeah.
So you can distribute. So they're going to
Oh,
be X, Y, X complement Z, Y, Z, X, and Y, Z, X complement. Right?
okay, okay. Yeah.
That makes sense?
Yeah.
So I can just go ahead and take this. Let me clean this.
Are you gonna take out the X?
Let's see.
Yeah, it looks like it's just making it more complicated right now.
Yeah, I haven't decided yet. So anyway, so now I need. Oh, scheiße, I'm sorry. Now I need to start looking at it. So how I'm gonna? Oh, sorry. How can I look at it? I can say this is equivalent to X ended with Y ended with. Is there is a place has X and Y here, right? So I can just one ORed with Z. Do you agree? Then I can also look to this one and this one together, right? And I say it's Z X complement with 1 and Y. Do you agree?
Oh.
Oh yeah, I see it. I see it now.
Okay.
Yeah. Okay. Uh-huh.
Okay, wait. One ORed with anything, it will be what?
A 1.
Exactly. So this is 1, this is 1. So now it's X and it was Y, ORed with Z, and it was X complement. What do you think?
Not bad.
Sorry,
Not bad, right?
what happened to the ones?
The ones is bye-bye, we don't need them. And
No.
it's like, Muhammad multiply, Muhammad ended with 1 is what? Muhammad.
Got it. Oh, because there's an and there. Got it. See it now.
So it's supposed to be really easy, right? Now, for instance, if I say if X, Y is equivalent to X ORed with Y ended with X ORed with Y complement. This is a very good example for who gonna be taken first, right? So X is gonna be distributed here and Y will be distributed, right? So X is gonna be X and it was X, and then ORed was X and it was Y complement, right? Those two terms came from the distribution of the X with this part, right? Then, one more time, then you're gonna what? And Y distributed, right? So gonna be X, Y, and Y, Y complement, right? Do you agree?
Wait, X, Y.
Then
yeah.
This one is equal what?
0.
0.
Thank you. This one is equal what?
1.
So gonna be X with X, Y complement with X, Y. Do you agree? We are not done yet. So this one and this one can be into X and it was 1 Y with X, Y complement, right? So this one, it will be what?
1.
0.
1.
Oh, wait. Oh, yeah.
Huh? 1,
Yeah,
right?
yeah.
So gonna be X with X, Y complement. right?
Mm-hmm.
What do you think? Cool, right?
Do you take out the x on this one too?
Yeah, that's what I was thinking.
I mean, let's try. Who knows? Maybe
Okay.
everything is possible in this life. It's up to you, right? But at least I can keep it like this if I want, right? But of course, if you like to look for less, sure, why not?
So just be x.
I mean, you try it. If you say one ord was like this, what is the value will be? So if y is equal 0, right? So that means, this combination will be 1. Do you agree?
Mm-hmm.
If y is equal 1, this combination will be what? Also 1. Right?
Mm-hmm.
Yes. Uh-huh.
Yeah, so it's correct, this one. Anyway, so
X
you guys
plus
understand
1.
you guys understand now how it works?
A little bit. Can you go back up a little bit?
Wait.
To the first question.
This one?
Yes.
Sure.
So I get the first part, right? You got the x. I still don't remember these. Anded with the y, the 1 plus z. But then what about the middle part? The y ended with z, ended with x. Where did that go?
You know what? Let's make this again. What do you think? Then we can discuss, because it was a big mess here. So let's do it one more time.
Okay.
Okay, let's do it one more time. As it's confusing. If I say f as a function of x, y, z is equivalent to x ended with y, x complement z, and y, z, right?
Mhm.
We call those guys terms. We call those guys terms. Okay? So how many terms do we have? We have 3 terms, right? Each term is representing a pair of variables, right? So basically, it's gonna be here. This is xy, this is x complement z, and so on, right? I'm looking for how can I decrease number of the how I can decrease number of what? Number of variables or literals, as they call.
Mhm.
Okay, so I'm from here I see in these 2 guys there is an x, right? Who is the only one doesn't have x?
The y.
That's why I started by this one.
Yep. That's
Makes
understandable.
sense?
Mhm.
So I can just say x, y, x complement z, and then y, z, 1.
Mhm.
Then I'll go further, x, y, s complement z, and then y, z, and then x, x complement.
Yep.
Then I'll go x, y, x complement z, and then I start distribute those, right?
Mhm.
So distribute those will bring me 2 terms out of 1 term. Do you agree?
Yes.
So which is gonna be what? It's gonna be x, y, z, or with what? X complement y, z.
See. Yep.
Right? Now we start and look into which one is similar. As you know, every single term has x.
Yep.
Right?
Mhm.
So now this one and this one are very interesting. Why? Because I can simplify one variable out. Right?
Yes.
So I can just write here x, y, ended with 1 or z.
Mhm.
Then this one and this one also very interesting, because I can also simplify one out. So gonna be here x complement z ended with 1 y. Right? Then I move forward. This term 1 ORed with z, what the output will be? 1. Right?
Mhm.
If you don't know it, we can do it. Look, if z equal 0, so this will be what? 1.
1.
If z equal 1, this will be what?
1.
1. Right?
Mhm.
So in that case, this is x, y with x
Oh.
complement z.
I guess it was the messy work. Okay.
Easy.
Yeah.
On the right, isn't it technically y plus y, not 1 plus y?
What is
What?
this? You mean here?
Yeah.
What's the
Isn't it,
problem?
isn't it y plus y?
Why? I'm talking about this term. What's this term? X complement z, I take it from this, it's gonna be 1. If I take x complement z from this one, it will just remain y. That makes sense?
Wait.
Yes.
I'm more confused now.
Why are you confused?
Hold on. So on the you don't have a z on the first one though.
Yes, that's true. Look, this one and this one brought me this.
Wait, which one and which one brought you that? This one? That one?
Yes. Can you do it? Take this guy aside, right? Multiply this into it, right? So x ended with y. It's gonna go inside the block, right? So it's gonna give you what? It's gonna be x, y. And then you're gonna go there x, y with z, x, y, z. This together is this one. And this is the second one.
Oh.
Make sense?
Okay. Yes, that does make sense.
And then the same thing here, right?
Mm-hmm.
Easy peasy lemon squeezy.
Yes.
Okay. Anyway, excuse me. Let me find you one more example. What about if I say f the function of x, y,
I get
z is equivalent to x complement, y complement, and then no. Let's make it more difficult. Z complement ended with x complement, y complement, z, and the whole entire thing will be complement. Very good practice for De Morgan. What do you think? Right? So what De Morgan said, we distribute what and what?
The terms.
Exactly. Let's distribute them. So they're gonna be, this is a term and this is a term, right?
Yeah.
So here is the term and here's the term, and this all will turn to be what? And.
And.
Right? Now the term is x complement, y, z complement, and I have this, right?
Mm-hmm.
The second thing is gonna be x complement, y complement, z, and I have this, right? Are we done?
No.
We have to move forward to break more, right? Let's break it. So this one will be breaking into what? X complement, complement. And this end will be what? Or. This y will be y complement. And this n will be or. This z complement will be what?
Complement.
Make sense?
Mm-hmm.
Then the second guy. So gonna be x complement, complement. Or was y complement, complement. Was ORed with z complement. Make sense?
Yeah.
Now let's go into this. Do you remember when I said about De Morgan? Those are even or odd?
Even.
So that means this is x. This is even or odd? Even. So gonna be here y complement and z. Right?
Mm-hmm.
Same thing here. Gonna be x, y, z complement. You can practice multiplying everything, right? Or distributing, right? If you want. So gonna be here x, y, x, z complement. Do you agree? That came from this distributed with this term, right?
Mm-hmm.
Then or the second, right? So gonna be y complement, let's work it to be more organized. X, y complement. Then y complement, and then y complement, z complement. So this came from this distributed in this term, right?
Yes.
Then ORed z gonna be xz with yz with z complement. Do you guys agree? This one got distributed here, brought me to 3 terms. So 3 terms ended with 3 terms. I'm expecting how many terms to come out? 9, right?
Mhm.
Now, simplify, right? This gentleman is x, right? So gonna be here x with x, y, x, z complement. Let's go down here. This gentleman 0, so gonna be x, y complement with y complement, z complement. Let's go into the third. Third, this guy is 0, so gonna be x, z, or with y, z. Right?
Mhm.
Any questions so far regarding what I'm doing?
Could you move up to the
We
the
can still
original?
even modify, by the way. We can still do some work. Do you like to see? This 3 guys can give me something fancy, right? Do you agree? What do you think? So let's try it. If I take x out of the 3, what will happen? So gonna be x ended with 1, y, y complement. Right? Hello.
Sorry, I'm processing.
Okay. The rest of you.
Sorry, is
Yes.
what happened to the x and z complement?
Where? I'm talking about this term and this term and this term.
Oh, okay. You're not looking at the x and z complement.
Yeah,
Okay.
we'll talk about this later. But did you see those 3?
Yes.
The 3 can be written like that, right?
Yep, makes sense.
Okay, then we can add to them this one. We can add to them this guy. We can add to them those 2 gentlemen, right? So gonna be here. You agree? Right? This one is what? Huh?
And 1.
This one is x, right? Because this is 1, or do is 1, 1. So basically gonna be here x with x z complement with y complement z complement with x z with y z. Right? Do you agree? What about this and this and this? What will happen? Same thing, right? You guys agree?
Yeah.
So gonna be here x, and here 1. Here gonna be z complement. Here gonna be z. And we OR with
Okay.
y complement, z complement, y, z. Right? This is what? This guy will 1. So totally gonna be x ORed with y complement, z complement, y, z. Any question?
Sorry. Where did you do the second one? The x ended with the 1 plus the or z, or with the z complement. Where's that one from?
Did you see these lines?
Yeah. Okay. So it's just from those 2.
From the 3. Yes. Right?
Oh. Okay. There's the other. Okay. There's the last one. Okay.
Okay. Can
That's
I?
it. That's not a double complement on that y, correct? Second to last line. Yeah.
No.
Okay.
No, I'm just like pushing like.
Okay.
Wait, Professor, could you scroll up just a bit?
Should I go more?
Yeah, if you don't mind.
Oh no, I was running. Damn. You're good. You're good. Don't worry about it. I think I get it.
Oh, okay, I see. All right, I get it now.
I promise I'm a really tricky person, by the way. You're gonna see in the exam. Anyway, but now I need to ask you a question, right? X, look at this. Let me think about it. It's really fun.
Wait a minute. Okay, that's the 0, so that's a 1. Okay, it's an X plus Y complement. C complement. Or with another Y and a Z.
I want to break this.
Can you put a 1
Huh?
on the Y and Z at the very back? Oh, but that won't do anything.
No, it will not help. There's a way to break it, but I didn't make it. So there is a very nice way to do it, but yeah. Just keep it like this for now. Anyway, but at least it's not bad. What we did now, we actually did a very nice practice for how to use De Morgan, right?
Mm-hmm.
So we still have 17 minutes. So I'm going to share with you something. And after that, we will conclude and we'll move forward to next time. And then next time I'm going to actually bring some questions from the back of the book so we can do it together.
Okay.
That sounds good. We just need more practice. I need more practice of this.
But I want you also to practice from the book.
Yeah, definitely.
So, in the end of the chapter, it's the problems here. They have from 2.1 to 231. So it has 231 questions. 2 to 31, that's not bad. 32 questions. So you can just practice. Let me see. I can actually leave some. Anyway, should we practice more or should I tell you the new topic? Which way you prefer?
I think practice more.
Yeah.
Okay, let's practice more.
Yeah,
and
that
next
sounds good.
time I will give you the new topic.
Yeah.
Yeah. Okay. I mean, it's not really hard. Let me get the problems here. I have a problem in front of me. Problems. So we can look into the problems, for instance, like number 2.2. Let's take the easy one. Let's say x, y with x, y complement like that. What is your strategy for simplifying it? It's a piece of cake. So basically going to be x.
1 plus y.
Make sense? You agree?
Yeah.
Okay. Let me find you one more. Like for instance, like this, f as a function of x, y, z is equivalent to x, y, z, ORed with x complement y with with x, y, z complement. How we can fix this problem? It's also a piece of cake. If I look at this and I look at this, all the complete terms have all of the variables in there. So I can just take x, y, z, ORed with z complement like this.
Wait. Oh, okay,
Yep,
yeah.
Here. Okay. Anyway, so this one is this one, and those two guys brought me this, right? So this one is equal what?
0.
Okay, 0 what is equal 1. So gonna be x, y, x complement y. So is there any more room for optimization?
Yeah, we can still pull out the y.
Yep, exactly. So in that case, we can just take y and it's gonna be x complement. So you're talking about y. So from 3 literals or whatever, 3 variables, we did downsize it to what? 1.
Can you do the y first? Take out the y from all of them.
You can, but I mean, the best strategy is actually to combine pairs. That's why, I start looking to what terms completely have all of them.
Okay.
Then after that, I start looking for list number of what's called variables combined together. That's why I took x, y together. You know what I mean?
Mm-hmm.
This is the way. So you try to eliminate one by one. Okay. Anyway, let me try one more time. What about this? This is actually cool. This is this is like A ORed with B ORed with C complement, and those guys are ended with A complement, B complement with C. It looks cool, right?
Mm-hmm.
So let's try to see it. So we basically know, if I look at it like this, how many terms I'm expecting to get out of this if I distribute?
No.
6 terms. It's a 3 terms times 2 terms, 6 terms, right? How? C distributed here, gonna give me 3 terms, right? So gonna be A, C, B, C, C complement C. Then this one will give me 3 terms, right? A complement, B complement, right? A complement, B complement. Then A complement, B complement, C complement. That makes sense? Are you guys following?
Yeah.
So now I see fun here, right? Why? This guy still exists, but this guy is bye-bye. C ended with C complement 0, right? Who is also bye-bye? This guy, because B complement, right? This one is 0 ended with A complement, so basically 0, right? So I can write it to be more clean, so to be A, C, B, C, and then the other last 2 term, which is basically this is also bye-bye, by the way, because A complement, right? So this also by, so end of the day we have this. So gonna be A complement, B complement, C complement. Do you guys agree? Easy peasy lemon squeezy. Let's try one more time, which is this is another problem, okay? So what about if it's A with B complement ended with A complement, B complement, complement? This is fun. Why? De Morgan with all the rest of the postulates, right? So if I look at it, it's gonna be what? Somebody help me. I want somebody to help me.
Be A complement and B complement.
And end it.
Uh-huh.
Okay.
Oh.
And
Ended with A and B.
that's what you're saying, right?
Uh-huh.
Okay. So we're done. Right?
Yeah.
That makes sense? Later on, that's gonna be a gate, by the way. Okay. I give you and an or and not, but I didn't give you the rest of the gates. Right? That will be later on. But anyway.
Professor?
Yes, sir.
Was the whole term being knotted, or the complement of it?
No,
what's
no,
that
no.
long
That was
line
just
at
a
the top?
line.
Okay.
Oh.
Sorry about it. I should use different color. Anyway.
So then why did the and between the 2 terms become an or if the whole term wasn't getting complemented?
It's a very good question. You're right. Let me see. Oh, you're right. Why I did that? Oh, it seemed that I put this in my consideration. You're right, like this. Yes. Yes.
So then if we distributed that, could it just
Then it still
all-
has to be distributed. Yes,
You're
you're right. It's actually equals 0.
Okay.
Right? You agree? I can do it here one more time. I will use different color. Different color, better. It's gonna be A, B, complement, right? Ended with A, complement, B, complement, right? So gonna be here, A, complement, B, ended with the A, B, right? They're gonna be A, complement, A, B, B with equal 0. Okay, Luke. Now let me find you one more problem. This is fun. I like it, you know, different color. So, you know, we will not make mistakes. Okay. The fun one, it say that, you know, A complement, C complement with A, B, C with A, C complement, and I want you to downsize this to reduce the following Boolean expression to indicate number of literals, and I will just need 3 literals. That means I just need 3 literals. That's it. I want it to be like completely squeezed. What is your strategy? Tell me, what should I do? I have an idea, but I will keep it for myself until somebody tell me. Yeah.
Pair one of the ACs with the ABCs. And then
Huh?
you can cancel out one of the C's. Like pair
You
the
mean
A.
those? Are you talking about those?
Oh wait, no, yeah. The AC, I mean, yeah. Pair those together, maybe. And then take out the A.
Do you think he's right?
If you got the C complement, it'll cancel.
Yeah.
So that will
Back up.
that will cancel A, right?
Yes.
Okay. So that basically what you're saying is gonna be A, B, C with C complement, right?
Yes.
And then what else will happen? Do you think that's enough, or we need to do something or what?
Can we take out the C?
How are we gonna do it? There is no way, right? This is C and this C complement.
That's true.
What about if you follow the same trick I made with adding 1? What will happen? You remember the trick I told you before?
With I guess you could do it with A plus A complement,
What will happen?
and then you can remove an A.
I mean, we can try. I mean, nothing will hurt us, right? We are in the stage of just trying. Okay, so we can put here B, for instance. So we can put B, right? Make it easy term. It has everything, so it will be straightforward, clean for me, so I can start what? Minimize, right? So I can just come in here and say A complement, C complement, A, B, C, then A, B, C complement, then I say A, B complement, C complement. You know how did these guys came, right?
Yeah, the +1.
Yeah, they came from here, right? That makes sense? Then what else?
You have 3 C
I can also do the same thing here.
Oh,
Then I can see at the end of the day how it's gonna look like, right? So I can come in here and say gonna be A complement, B, C complement,
fine.
A complement, B complement, C complement, A, B, C, and A, B, C complement, A, B, C complement, right? Do you agree?
Mm-hmm.
Now we can start what? Optimize, right?
Yeah. Second term and the last term both have B and C complements.
Let me check. This one and this one.
Yeah.
Right?
Mhm.
Then let me have a different color if we'd like to point on another one. Is there anything else we can point to it?
The A and
This
B.
one and this
Yeah.
one.
Mhm.
Right?
Yeah.
So I can come and say this is A, B, C complement, and these two guys will have B complement, C complement, right?
Mhm.
And these two guys will have AB, right?
Yep.
Then still I need to do something. Let me see. One second.
I think that's the simplest.
No.
Wait, Professor, couldn't we take out the A from the A, B complement, C complement, and an A from the A, B, C? Then you would just have A times B, C plus B complement times C complement, which would just be 1. Then you'd have A.
Let's try it again. So what you're saying?
So to take out the A from the, I think
Okay.
that's like purplish, the A, B, C.
You want this?
Uh,
No,
the
you
one
mean this.
top.
The
Yeah,
top
that one.
Okay.
And to take out the A from that one and like right below it, the A with the B complement and C complement. So then
You
you would
mean
just,
this?
yeah,
So there's two guys together, right? So basically that's what you're saying. A, B, C, B, C. Okay.
right.
And then?
And then where can you go from there?
And then what about those guys?
Yeah, then with the, let's see.
Then you could do the same with those two, right? You take out the A complement.
Where? You mean here?
Yeah, those two. The first one and the second one. Yeah.
Oh, you mean those, right?
Yeah.
Okay, they're gonna be or with what? A complement, right? And then what? They're gonna be a B, C like this,
Mm-hmm.
right? And
a B complement, C complement. Yeah.
okay, and then how many terms we have? We have 5. So there's one more term. Who is the extra term?
The ABC complement, I think.
Yeah.
Right? Okay.
I think there's an easier way to have done that.
There is much either way. So we just keep it for next time. But
All right.
there is a way actually do it with something is called K-map. I can just do it for you one shot.
One shot.
Yes. It's like, you know, like you don't even need to do all of this. We're gonna learn this in the chapter 3.
Man,
It's-
like
Wow.
all this A, B, and C. This
It's like
these two
one
letters
shot.
is
Like you
messing
know,
me up right now.
I mean, like, you know,
I
this
kind
is
of
the
get
best.
it though.
I think we could have taken out the B, but I think
Originally, from the original equation.
no, from the ABC and the A complement B C complement, and then you would have B times A complement C complement plus A times C, and then you'd get the same thing that goes to 1.
Wait,
So you have
what do you
A-
want? What do you want?
Oh, so from the very first term of A complement times B times C complement, and then if you take the second to last term A, B, C, C complement, or sorry, where am I looking?
You're talking about
yeah.
this, like this.
Oh, wait,
That's what we
am I
did,
on
right?
The right one? Is that what we? Oh,
That's what we did before.
I think that's, yeah. Never mind. I'm looking at the wrong term, I think.
I will show you something later on. You know, this can be fixed in something called K-map. It will take 1 minute, less than a minute. Let's see if I have more time. I think we have 3 minutes. I don't think 3 minutes will be enough for a problem to solve or not. But, do you guys like to have one more problem, or you know we are done for today? It's up to you.
I think I'm gonna digest the first problem.
Yeah, I gotta look at that
This
too.
one, keep it for next time, for sure.
Okay.
Okay, because you know we are done with this. But you know, can you do me a favor? I just want you to do your best and practice from the book, right? Here are the problems. Use a bunch of problems.
We're supposed to have the book.
Okay. So you know, give a bunch of these problems, and you know, just do it. You know, make sense?
Yeah.
Yep.
Okay. Anyway, so we can stop here today and say, you know, it was my pleasure to talk to you guys, and thank you. And I'm looking forward to talk to you on
Next week?
Monday.
Yeah,
Next
Monday.
week, yes. So have a nice weekend. Enjoy solving problems, and you know, and keep me updated if you need any help. And God bless you. Thank you.
All right.
Thank you, Professor. Awesome.
Thank you, Professor.
Bye-bye.
Have a good one.
Professor, I added a chart to the Slack that kind of talks about some of the properties for
Okay, perfect.
Boolean
Thank you.
algebra. Yeah, you bet.
Thank you. I appreciate it. Thank you. Bye.
Yeah, no worries.
Thank you. Bye.